In the previous video, we have proven the identity where the product of reflection and the rotation is equivalent to a certain form as well. This time, it's not the product of a rotation and a reflection, but we need to understand the given identities for each. For the rotation of your theta, it's actually equal to this expression, cosine of your theta, sine of your theta, negative sine of your theta, and you have here cosine of theta, which will be multiplied to the components of your x, right? For your reflection of your phi, we're using here phi because that's what what's in here is actually to be multiplied. This identity is equal to the cosine of twice theta, sine twice theta, sine twice theta, and the negative of cosine twice theta, still to be multiplied with the components of your x. Let us use the portion here for this identity as we show the proof of the item intended here. So our proof here will start with the rotation of your theta times the reflection of your phi. So simply multiply the given identities except for the components of x. So you have here cosine of theta, you have sine of theta, negative sine of theta, cosine of theta, to be multiplied with cosine of twice theta, sine of twice theta, sine of twice theta, negative cosine of twice theta. Okay, take note we are multiplying matrices, and this is actually what equals 1. Define 2 by 2 times 2 by 2, we will get 2 by 2 as well. So the product of that would entail the use of proper matrix multiplication. First, this one to be multiplied with this column. So you will have to get cosine theta. Sorry, my bad. This should be phi, right? Okay, this one here. Oh, my bad. This should all be phi because we're using here phi. Sorry, twice phi, twice phi, twice phi, twice phi. Similar here, 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 and here. Sorry for that. So cosine theta times cosine twice phi plus for this and here, you will actually have negative sine theta times sine twice phi. Okay. Next, this one in that column. So you have sine theta cosine twice phi. Sorry, that's phi. Then plus cosine theta sine twice phi. Sorry. Okay. For the next one, this and this column. So you will have here cosine theta sine of phi plus negative sine of theta times negative cosine of phi. Okay. Then for the last one, sine of theta sine of twice phi plus you'll have here cosine of theta times negative cosine of phi. Okay. Just simply try to simplify the signs. Cosine theta cosine twice phi minus sine theta sine twice phi. Then you have here sine theta cosine twice phi plus cosine theta sine twice phi. At the top, multiply negative, so it's positive now. You have here cosine theta sine phi plus sine theta cosine phi. Take note, this is just the same as that. It's just that the second term is the first term here, and the second term here, the first term there. So they're just the same. So whatever be the result later on using the sum and difference formulas, so they will have the same result. As for the bottom, you have here sine theta sine twice phi minus cosine theta cosine twice phi. This is the you can see here that it's actually negative at this time, positive here, negative here, positive there. So it actually has a factor of negative. Okay, so allow me to add another space here. Cosine theta cosine twice phi minus sine theta sine twice phi. Sine theta cosine twice phi plus cosine theta sine twice phi. Allow me to rearrange this to meet this specific form. Again, they are just the same. Sine theta cosine twice phi plus cosine theta sine, by the way, oh my god, sorry, you should have actually, sorry for that, this has twice, my bad, I missed some important aspects here because this is for reflection. Twice phi, that would mean for all the result here, this would be twice phi here as well. My bad, I'm so sorry for this mistake. I'll be erasing some concerns here. Cosine twice, again, twice phi here as well. Let me change the color. Oh, sorry. I was actually thinking different perspective because I would like to save some spaces. Twice phi here as well. That would be true for the next few items as well. Twice phi, twice phi, twice phi here. So you will have to use twice phi, twice phi, twice phi, twice phi. So carry over here twice phi as well. Okay. So you have your sine. Sorry. What I would like to do here in the last one is, if I'm going to factor negative and rearrange that, I will have cosine theta, cosine twice phi. The negative was actually taken out. And what happens to this positive portion here, specifically this portion here, when I factor negative, it will become negative now, sine theta and sine twice phi. I'm doing that so that this will be similar in the perspective. Okay? So now, I can now use the sum and addition formulas for specifically for cosine and sine. The first item here is actually the cosine of the sum of theta plus twice phi. Okay? At the bottom is also the sum formula for sine, which is also here, the same here, plus twice phi. And at the last one, you have negative, and you have the cosine of the sum of theta and twice phi. Okay? So this is actually a more simplified form, and this fits the criteria of reflection as the negative is on the last entry. Here, negative. This means it is equivalent to the reflection. So what reflection? Supposedly the reflection of an angle, supposedly it would look like this, right? But this is not our goal. It has actually a fraction form here. So how is it possible? Take note that if we're going to talk about reflection, and again, this fits reflection, okay? That's without a doubt a reflection. But when you talk about reflection, the certain angles here are doubled. But the notation to be used here is just half of whatever the result here. So taking the half, okay? Unlike rotation, that the same angles are indicated here, for reflection, if it's the angle here are all the same, for this notation, you take the half of that angle, pair it for reflection. In short, this is double. So say for example, if that's twice b, theta plus twice phi, for our beta to be intended here, because this is not correct, we divide both sides by 2, you have theta over 2, plus you will have your phi. Okay? So looking at our perspective, yes, it fits now, phi plus theta over 2 or theta over 2 plus phi. It's up to you. You can rewrite this as well just to fit with our intended output. So that's what we need to place here, not this angle because that's twice. In short, the final form here is the reflection of your phi plus theta over 2, or of course, you could also write this as theta over 2 plus phi. We have shown this identity to be true. So in short, the next time you're asked to identify the product of a rotation of a certain angle and its reflection, you can simply use this identity, just the reflection itself of the phi angle, which is for the reflection, and add it to the half of your theta for the angle original for your rotation. Thank you very much for watching.